Alright, so in this problem, I have 81 to the power of x is equal to x to the power of 18. So I want to find the value of x here. So for my solution, I'm going to rewrite this equation. So 81 to the power of x is equal to x to the power of 18. And now, I'm going to take the power of 1 over x on both sides. So I get 81 to the power of x to the power of 1 over x is equal to x to the power of 18 to the power of 1 over x. And now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 81 to the power of x times 1 over x is equal to 81 to the power of 1, which is the same thing as 81. So I get 81 is equal to x to the power of 18 to the power of 1 over x. And x to the power of 18 to the power of 1 over x is the same thing as x to the power of 18 times 1 over x, which is the same thing as x to the power of 18 over x. Now I'm going to take the power of 1 over 18 on both sides. So I get 81 to the power of 1 over 18 is equal to x to the power of 18 over x to the power of 1 over 18. And this is the same thing as 81 to the power of 1 over 18 is equal to x to the power of 18 over x times 1 over 18, and these two 18s cancel out, so I get 81 to the power of 1 over 18 is equal to x to the power of 1 over x. Now, 81 here is the same thing as 9 squared. So I'm going to rewrite this as 9 squared to the power of 1 over 18 is equal to x to the power of 1 over x. And now this is the same thing as 9 to the power of 2 times 1 over 18 is equal to x to the power of 1 over x. And 2 times 1 over 18 is the same thing as 1 over 9. So I get 9 to the power of 1 over 9 is equal to x to the power of 1 over x. Now, notice how this is in the form a number to the power of 1 over that same number is equal to x to the power of 1 over x, meaning x is equal to this number 9. So now, going back to the original equation, let's go ahead and check if this is right. So I have 81 to the power of x is equal to x to the power of 18. So x is equal to 9. So if I plug in 9 for x, I get 81 to the power of 9 is equal to 9 to the power of 18. Now, 81 is the same thing as 3 to the power of 4, and 9 is the same thing as 3 squared. So I get 3 to the power of 4 to the power of 9 is equal to 3 squared to the power of 18. And if I have something in the form a to the power of m to the power of n, that's equal to a to the power of m times n. So 3 to the power of 4 to the power of 9 is equal to 3 to the power of 4 times 9, which is 3 to the power of 36. And this is equal to 3 to the power of 2 to the power of 18, which is equal to 3 to the power of 36 as well. So this is right. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. Make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have x to the power of 3 minus 27 is equal to 0. Now, I'm trying to find the value of x here. So, for my solution, I first start with x to the power of 3 minus 27 is equal to 0. Now, 27, this is the same thing as 3 to the power of 3. So now if I substitute in 3 to the power of 3 for 27, I get x to the power of 3 minus 3 to the power of 3 is equal to 0. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, a is equal to x and b is equal to 3. So now I have x minus 3 times x squared plus 3x plus 3 squared. That's equal to x minus 3 times x squared plus 3x plus 3 squared, which is 9. And remember, this is equal to 0. So now this gives me two equations. I have x minus 3 is equal to 0, and I also have x squared plus 3x plus 9 is equal to 0. So for x minus 3 equals 0, all I have to do is add 3 on both sides. These two cancel out, and I'm left with x is equal to 3. So this is one solution. Now for x squared plus 3x plus 9 equals 0, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now in this case, a is equal to 1, b is equal to 3, and c is equal to 9. So now I have x is equal to negative b, so negative 3, plus or minus the square root of b squared, so 3 squared minus 4 times a, which is 1, times c, which is 9, all over 2a, so 2 times 1. So now I have x equal to negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times 1 is 4, 4 times 9 is 36, all over 2 times 1, which is 2. And now I have x equal to negative 3 plus or minus the square root of 9 minus 36. That's equal to negative 27 over 2. And now negative 27, the square root of negative 27, I can rewrite as the square root of 27 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1, this is actually equal to the imaginary number I. So now, if I replace I with the square root of 27, or sorry, the square root of negative 1, I get negative 3 plus or minus the square root of 27, I over 2. So these are two other solutions to this problem. So now my first solution, this is 3. My second solution, this is negative 3 plus the square root of 27i over 2. And my third solution is negative 3 minus the square root of 27i over 2. So these are my three solutions to this problem. Alright, so I have 2 to the power of x is equal to 5. Now I want to find the value of x. So for my solution, I first start with 2 to the power of x is equal to 5. Now I'm actually going to take the log on both sides. So now I have log 2 to the power of x is equal to log 5. Now, an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this is going to equal b times log a. And this property is actually so important because, as you can see, right now we have 2 to the power of x is equal to 5. And x here, this is an exponent, and it's going to be really hard to find the value of x without it being a normal term because x is actually going to be a decimal here. 2 to the power of 1, this is equal to 2, and 2 to the power of 2, this is equal to 4, 2 to the power of 3, this is equal to 8. So 5 is somewhere between 4 and 8, so the value of x is going to be somewhere in between 2 and 3, and it's going to be a decimal. So now by using this property, I can move x to the front, and then now I can find the real value of x, the exact value I mean. So I had log 2 to the power of x is equal to log 5. Now by using this property, I can move x to the front. So now I have x times log 2 is equal to log 5. Now, if I divide both sides by log 2, these two cancel out, and I am left with x is equal to log 5 over log 2. Now, the value of log 5, this is equal to 0.6990. And the value of log 2, this is equal to 0.301. So now I have x is equal to 0.6990 over 0.301. And if I divide these two, I get x is equal to 2.32. So this is my answer. Alright, so I have 2 plus 2 is equal to 5. So let's first start with 0 is equal to 0. This is a true statement, right? 0 is equal to 0 because any number is equal to itself. So on my left-hand side here, I'm going to rewrite 0 as 20 minus 20. And 20 minus 20 is 0. So this is right. I'm not doing anything that is illegal here. And for my right-hand side, I'm going to rewrite 0 as 25 minus 25, which is also equal to 0. So I'm not going out of the rules or anything. Now, 20, this is the same thing as 4 times 5. So now I have 4 times 5 minus 4 times 5 is equal to 25. This is 5 times 5 minus 5 times 5. So again, I'm not going past the rules or anything. 20 is equal to 4 times 5, so I simply substitute in 4 times 5 for 20, and same thing with 25. 25 is equal to 5 times 5, so I simply substitute in 5 times 5 for 25. Now, this is the same thing as 4 times 5 minus 5. All I did was I factored out 4 from this because both terms were being multiplied by 4. And now this is the same thing as 5 times 5 minus 5. All I did was I factored out 5 from this because 5 is being multiplied by both terms. So now what I'm going to do is I'm going to divide both sides by 5 minus 5. So then these two cancel out and these two cancel out. And now I'm left with 4 is equal to 5. Now 4, this is the same thing as 2 plus 2. So I have 2 plus 2 is equal to 5. And there it is. I just proved that 2 plus 2 equals 5. However, this is actually wrong. And somewhere in solving this, I actually made a mistake that you cannot do in mathematics. So as you can see here, I had 4 times 5 minus 5 is equal to 5 times 5 minus 5. Now 5 minus 5, this is actually equal to 0. So now I have 4 times 0 is equal to 5 times 0. And what I did was I divided by 5 minus 5 on both sides. And if you guys already didn't know, dividing by 0 is not defined because anything divided by 0, well, as you see 4 divided by 0, if we tried to do this, 0 times what equals 4? Well, nothing, because you can't multiply anything by 0 to get 4. 0 times anything is 0. So dividing anything by 0 is undefined. So when I divided both sides by 5 minus 5, I really divided both sides by 0. And now 4 times 0, so now if we do this, 4 times 0 divided by 0, this is 0 over 0 is equal to 0 over 0, and 0 divided by 0 is undefined. So this, you can't do this. So dividing by 0 it can lead to weird results.